The National Grid Network. By the end of this lesson, you should be able to state the importance of the National Grid Network, solve problems involving electricity transmission, Power stations are normally built near the energy sources. Hydropower stations, for example, are built at high-altitude rivers, so the potential energy of flowing water can be tapped to run the turbine. Coal power plants are built near seas or rivers, where coal and water for cooling purposes are available. Normally, power stations are located far away from towns and industrial areas and are called load centers. How is the electricity produced at the power stations delivered to consumers? A grid network system consists of high-voltage transmission lines interconnecting all the major power stations and substations at load centers. Why is high voltage used for transmission? The overhead cables may be hundreds of kilometers long and have small resistance. As current flows through the cables, power is wasted as heat. To reduce power loss in the cables, a step-up transformer is used to increase the voltage to 132,000 kilovolts or higher. To transmit the same amount of power, the voltage is stepped up. From P equals VI as the voltage is increased, the current I that flows in the overhead or high-tension cables is reduced to a very low value. Thus, power loss in the cables will be much reduced. Is the demand of electrical energy constant all the time? In Malaysia, the demand during the day is higher than that at night. The average maximum demand during the day is over 12,000 megawatts, and it drops to about 8,000 megawatts during the night. The demand during the weekdays is higher than during weekends and public holidays. How is the operation of the grid system monitored? The operation of the grid system is monitored 24 hours a day by the Grid System Control Center in West Malaysia. The control center is called the National Load Dispatch Center, NLDC. Do you know who is responsible for the planning and the operation of the grid system in Malaysia? The planning and the operation of the grid system are under an organization called the Grid System Operator, which is currently one of the departments under Tenaga Nasional Berhad, TNB. Do you know how much the electricity generating capacity in Malaysia is? In Malaysia, the total installed generation capacity as of 2006 is about 18,500 megawatts, of which less than 1,000 megawatts is in East Malaysia. How many major power stations are connected to the grid system? There are about 30 major power stations in West Malaysia connected to the grid system. 9 major power stations are connected to the grid system in Sabah, and 6 major stations are connected to the grid system in Sarawak. However, the grid systems in West Malaysia, Sabah and Sarawak are not interconnected. Mouse over the markers to view the names of the power stations. How is the operation of the grid system managed? The grid network needs to be managed properly in order to provide continual and reliable supply to the consumers. The management of the grid system is basically to balance the supply and demand of electricity in the grid system by the most secure and economical way. What action needs to be taken when there is a sudden increase in demand of power supply? If the electricity demand of the grid system increases suddenly, the power supply to the grid network needs to be increased quickly in order to meet the demand. What action needs to be taken if a generating set in supplying electricity to the grid network suddenly trips? Other power stations can supply electricity to consumers in the affected areas through the grid network. The graphic shows the simulation of how a grid system is managed under different scenarios. Consider a simple grid system interconnecting 5 different types of power plant with a total capacity of 1,200 megawatts, supplying electricity to 10 load centers with a total load of 900 megawatts and a transmission loss of 20 megawatts. That is, the total demand of the grid system is 920 megawatts. During normal working days, generating plants G2, G3 and G4 with a total capacity of 1,050 megawatts will be run at about 90% capacity to supply the grid demand of 920 megawatts. What action should be taken if the 150 megawatts G3 generating plant trips? The remaining operating generating capacity will be 900 megawatts, that is, 300 megawatts supplied by G2 and 600 megawatts supplied by G4. As the total load is 920 megawatts, while the generating capacity is only 900 megawatts, the supply is not able to meet the demand. The most appropriate action is to run the 50 megawatt hydro plant G5 to supply power to the grid. hydro plant has the advantage of being able to be in operation in a very short time. By operating G5 to supply power to the grid, the total generating capacity supplied to the grid will increase to 950 megawatts, which will be able to meet the demand of 920 megawatts, and yet with some spare capacity to cater for any small fluctuation in load demand. The grid system is secure, and the consumers will not experience any interruption of power supply. What action should be taken if the 300 megawatt G2 generating plant trips? The remaining operating generating capacity will be 750 megawatts, for example, 150 megawatts supplied by G3 and 600 megawatts supplied by G4. As the total load demand is 920 megawatts, while the generating capacity is only 750 megawatts, the supply is not able to meet the demand. The appropriate action is to quickly run the 50 megawatt hydro plant G5 and a 100 megawatt open cycle gas turbine power plant G1, increasing the power supply to the grid to 900 megawatts. However, this is still not sufficient to supply the load of 920 megawatts. As such, at least 20 megawatts of load must be disconnected from the grid in order to balance the mismatch between supply and demand. Thus, there is a need to shed off or reduce load. The most appropriate load center to be shed off is L1, which demands 30 megawatts. This will reduce the load of the grid system to about 890 megawatts, which will be met by the generating capacity of 900 megawatts. Slightly more load is shed to cater for any fluctuation in the loads. By running the generating plants G1 and G5 to supply power to the grid, and at the same time shedding off L1, the total generating capacity supplied to the grid will increase to 900 megawatts, which will meet the demand of about 890 megawatts, and yet with some spare capacity to cater for any small fluctuations in load demand. The grid system is secured, and the consumers, except those at load center L1, will not experience any interruption of power supply. A big factory requires a power supply of about 200 megawatts. The present grid system is not able to provide the required capacity of power supply. What would you do to solve this problem? A combined cycle power plant of capacity 250 megawatts can be built near the load center, that is the new factory. Why is a combined cycle plant preferred to the other types of power plants? The combined cycle plant is preferred because the construction time of a combined cycle plant is about 2 years, while the construction time for a coal-fired power plant is more than 3 years. 2. A combined cycle power plant is more efficient and cheaper to operate as compared with an open cycle plant. Even though the initial building cost is higher, the overall running cost is lower for a combined cycle power plant. 3. By building the new power plant near the factory, the power loss in transmission will be reduced. What are the other problems related to the network and how to solve these problems? A model of a 275 kilovolt 50 Hz grid system interconnecting 5 different types of power plant, G1 to G5, has been set up. Total capacity of the grid system is 1,200 megawatts, supplying electricity to 10 load centers, L1 to L10, with a total load of 900 megawatts, and experience a transmission loss of 20 megawatts. That is, total demand of the grid system is 920 megawatts. Normally, generating plants G2, G3 and G4 with a total capacity of 1,050 megawatts will run at about 90% capacity to supply the grid demand of 920 megawatts. The aim of this activity is to operate the grid system to ensure continuity of supply to the consumers, to minimize the areas affected by interruption of supply, and to prevent total blackout of the whole grid network if certain events happen on the network. Click on the Start button to switch on the supply. If the part of the grid network between point A and point B is suddenly disconnected from the grid system, what is the appropriate action to be taken? Click on the generating plant that you think is most suitable to come to the rescue. If load center L7 is suddenly cut off from the grid system due to tripping at the main intake substation supplying power to L7, what is the appropriate action to be taken?